project. All right, so here's our equation. Here's where we started out with, and we're going to work with an exponential. But we began today's lesson looking at this equation. So write this down. Three things we need to find, K and B, which you've actually already found both of those. Well, you haven't found B yet, but you found period length. And then the last part is finding A. Now, what's different with this scenario is A is changing, right? And you just looked at a changing linear function, and it kind of models the data, but it's not perfect. Now we're going to look at an exponential model. To do this, we are going to rewrite our equation, and I'm not going to use P, I'm going to use T. D of T, or D of time, is equal to a linear function or an exponential function. Now if we look at an exponential function, we're going to go back to chapter 3. A times m, and m represents your b, but I don't want to introduce another b because you might get confused with this one, to the time plus k. Now we just solved for which letter? K. What is our k value? All right, 22.175, and I know this is a times m to the t.
Is the k adding to the t or adding to the m of t?
The k is going to just add to whatever we have here. Okay? Now, earlier on when you guys were saying exponential, were we speaking of growth or decay? So this is visually what's happening, and it's easier to see it this way. You're predicting that the data is going to do this. It's going to go down, and it's going to run right along an asymptote. And where's your asymptote at? It's at the midline, which is 22.175. So if that's the case, what are the two letters that I need to find? A and M. Now, I want to point this out. 1.7. You guys are all writing this down, right? Okay, just making sure. These are probably the most important notes I give in Chapter 6. And 20, what's the date on this? 26.746. Good, that's my first data set. My second data set, we'll just say is 3.4, and I think it's 26.553. Okay? All right, so those are my two data points. These are the ones we use for the linear equation. These are the ones we're going to use for this one. All right, if this is the case, talk to your team. How can I use these two data points to solve for A and M? Any ideas here? I got to solve for two letters, A and M. Raphael?
You would put the y of each of the coordinates in the d of t.
Okay, so my d of t, that's exactly right. That's my output. And my input's going to be t, right? Okay, so what am I going to do with this? Raphael?
You plug in for example, first you plug in the 26.746 to the d of t, and you plug in the 1.7 to the t.
Okay. I like that. It's a good way to start. Equals a times m to the 1.7. Keep your vertical shift with it. Plus 22.175. All right, I love Raphael's strategy. This is great. We have one equation. However, we have an issue with doing this. What's the problem? Two variables. Can we solve?
No.
We can't solve with two variables. We need to do something else. Shannon?
You need to do the same exact thing for the other equation, put it under it, and then start eliminating until you have...
Good. We're gonna construct a system, right? This should make a lot of sense. If you are only using one point, think about this. I take away this point. You're just using this point. Can you make an equation for it? You don't know what it's going through, do you? You have to have 2 points, which means you have to have two equations. Set up your other equation right underneath. Good. This is called a system. You do this in Frank's class. You do it with linear functions. Now in my class we're doing it with exponential. This is what we did in Chapter 3. However, we can't solve for A and M until I take care of this. This is making it more complex. So you need to do a little algebra. Take care of this with your team. Both of them, on both equations. Alright guys, you should be subtracting 22.175. We want to make our lives a little bit easier. Subtract it from both of them. And this will just give you a more simplified form. So when somebody has the top equation, let me know what those numbers are. 4.571 equals a times m to the 1.7. Do the same thing for the bottom. What's the bottom? 4.378 equals a times m to the 3.4. Okay, we're almost ready to eliminate. However, I told you this back in chapter 3, there's too many m's down here. Remember, you're going to get a negative exponent. So how do we make that easier for us? Shannon?
We make it a fraction, and then you cross out the a's, you put it at the end to solve, and then you just solve for n.
Okay, we are going to do that, but to make our lives easier before you divide. Jamia?
Don't you cancel some out?
Even before that, Moy?
Simplify the 1.7, 3.4.
Even before that, Martin. Put this on the top. Make your life easier. Great ideas, guys. You're one step ahead, though. All right, so switch the order of them. So put the 4.378 on the top. And I know that's a subtle thing. I mean, you could have still worked with it. It would have just made your life a little bit more challenging. Okay, now you get to where you were talking about. We want to eliminate. Now we can make proportions. You might remember this. And what eliminates? The a's are gone. Okay, now make sure you remember your rules of exponents. See if you can go ahead and solve for m. What's this 4.378 divided by 4.5? 0.958. Okay, or 9.7. A's cancel. Now, do we divide here? You subtract. 3.4 minus 1.7, which is 1.7. Almost done. We got to get rid of that 1.7 as an exponent. Jamia? Great. Use the reciprocal. It's way easier. 1 over 1.7. 1 over 1.7. So keep that answer in here, whatever is in here, keep that carried over, take it to the 1 over 1.7 power, and then tell me what you get for m. .97. Okay, yeah, let's see what I have in my notes. 0.975. Okay. Fine. Good, I got my m. Are we done? No, you got to find what now? A, all right? You could use this equation, right? You got to go all the way back to the beginning. Is this smart? What's a better equation to use? One of these. They're more simplified. They're the same thing. You're just not dealing with this plus 22. So I would use either, yeah, you can use one of these. Go ahead, solve for A. All right, guys, keep your answer as specific as you can. You should have got 4.77 for A and 0.975 for M. Let's go ahead and write our final equation now, at least for the exponential. You'll get y equals 4.77 times 0.975, and it helps the more accurate you are, at least with your calculator, to the t plus 22.175. Raise your hand if you're able to put this in your calculator. Some of you? How did it look, guys?
It didn't show.
Okay, well, for most of you, it sounds like it went through most of the points, right? It should have nailed it. It's actually a better model than the linear model. And if you think about it, that should... Okay, I'm going to work through this with you. Guys, this entire equation, which you just found, is our A. So when you are writing this, it's going to look like this. Y equals And all of your A, which will go right in here, 4.77, I'm going to have to write small to get it all on here, times 0.975 to the T. Now, you could write in the plus 22.175, but look at our original equation. It's already here. Why is this K the same thing as the K in the sinusoidal function?
That's where it starts.
Because K is the midline, or equilibrium in the sinusoidal function, and it's also the asymptote in the exponential. Are they approaching the same place? We don't have to be repetitive. So we have our A in here, and now we will add the cosine times cosine. What's my angular frequency? 2 pi over 1.7, which is my period length, x. This is going to be more accurate. And then we can add now 22.175, which is my K-shift. And actually, I made the same mistake yesterday. Guys, don't write x in here, write t, because t is your time, so you're dealing with the same variable.